Hello and welcome. This video presents Module 3 Spatial Analysis for the Environmental Information System EVT554. This module focuses on spatial analysis, one of the most important functions in GIS. Spatial analysis transforms raw geographic data into useful information. It helps solve location-based problems, identify relationships between features, detect patterns, assess trends, and support better decision-making in environmental management. The learning outcomes of this module are to understand spatial analysis tools, to create buffer and overlay analysis of spatial data, and the last one is to merge two or more feature classes into a single dataset. The first practical exercise is buffer analysis. A buffer creates a zone around a geographic feature based on a specified distance. Buffer analysis is commonly used to identify protected areas, safety zones, or areas affected by environmental activities. First, ArcMap is launched and river.shp is added into the table of contents. Next, Arc Toolbox is opened. Under Environment setting, the Data EVT folder is selected as both the current workspace and Scratch workspace. After that, the Buffer tool is opened from Analysis Tools, Proximity. The input feature is river.shp. The output feature class is named river buffer 300.shp. The buffer distance is set to 300 meters. For the first analysis, the dissolve type is set to all before running the tool. After processing is complete, the buffer zones merge into a single polygon wherever they overlap. As a result, the attribute table contains only one record. The same process is repeated, but this time, the dissolve type remains known. With this option, every river feature produces its own individual buffer and overlapping areas are not merged. The next spatial analysis tool is Union. Union combines multiple polygon layers into a single dataset while preserving all geographic features and attributes from every input layer. The Union tool is opened from Analysis Tools, Overlay. The input layers are District, Kelantan.shp and River.shp. The output layer is named Union.shp. After running the process, the attribute table is opened to examine the results. The analysis is repeated using Malaysia.shp together with the previously created Union.shp. Union analysis is useful for combining multiple datasets into one comprehensive layer for environmental analysis and planning. The next overlay tool is Erase. Erase removes portions of one layer based on another layer. The Erase tool is opened from Analysis Tool, Overlay. The input feature is District Kelantan.shp. The erase feature is river.shp. The output is saved as erase 1. The process is then repeated using Malaysia.shp as the input feature and Kuala Lumpur.shp as the erase feature. Erase analysis is useful when unsuitable or restricted areas need to be excluded from further environmental analysis. The final overlay tool is Intersect. Intersect identifies only the areas that are common to all selected layers. The intersect tool is opened from Analysis tool, Overlay. The input layers are river.shp, district Kelantan.shp, basin Kelantan.shp. The output feature class is named intersect1. After processing is complete, only the overlapping areas shared by all three layers remain. The same procedure is repeated using boundary klangvalley.shp, Kuala Lumpur.shp, road klangvalley.shp. Intersect analysis is useful for identifying areas where multiple environmental conditions happen at the same location. Discuss how the results differ between dissolve all and dissolve none in buffering. When would this be important? Okay, let me explain. Dissolve all merge all overlapping buffer zones into one polygon. The attribute table contains one record if all buffers are connected, suitable for creating a single protection or management zone. For example, creating a 300-meter protected zone along a river. Dissolve none keeps each buffer as a separate feature. The attribute table contains multiple records, one for each buffer. It is suitable when each feature needs to be analyzed individually. For example, analyzing the protection zone of each river segment separately. It is important after inspection. Remove the dissolve none layer if it is no longer needed to avoid duplicate data. Explain each overlay analysis done in this practical. There are 3 overlay analysis done in this practical: union, erase, and intersect. The first one is union. It combines 2 or more layers into a single dataset. Preserve all features and attributes from every input layer. In environmental application, it is combining land use, rivers, and administrative boundaries for environmental planning. The second one is erase. It removes areas of one layer using another layer as the erase feature. It produces an output without the erase area. In environmental application, it removes protected areas or water bodies from proposed development sites. And the last one is intersect. It attracts only the areas of overlap between all input layers. Keeps only the common geographic features. Environmental application, identifying flood risk area where rivers, drainage, and administrative boundaries overlap. How many records do the intersect results have? The number of records depends on the input datasets. It is equal to the number of overlapping features found after the intersect analysis. To determine the exact number, open the attribute table of the intersect output and check the total number of records. Highlight all spatial analysis performed in this practical and relate the function of each analysis with real applications in the environmental context. Okay, there are 4 spatial analysis performed in this practical. The first one is buffer. The next one is union, erase, and the last one is intersect. buffer can create a zone around geographic features. In environmental application, it can create river protection zones, pollution control zones, and safety buffer areas. Union combines multiple spatial layers into one dataset. It helps to integrate land use, rivers, and administrative boundaries for environmental planning. Erase removes selected areas from a dataset. It can help to exclude protected forests, lakes, or conservation areas from development planning. And the last one is intersect. It can identify overlapping areas between layers. In environmental application, it can help to map flood risk area, habitat suitability, and environmental sensitive zones.